Find the indicated limit if it exists. The limit of the square root of x to the fourth minus 4, and then outside the radical we have minus x squared. We're taking the limit of this entire function as x approaches negative infinity. If we try to use direct substitution in here, negative infinity to the fourth power will become like a positive number, or a high negative number would become positive when we substitute it in and evaluate it to the fourth power, minus 4. So we would have and then minus x squared, we would end up having an infinity minus infinity answer. So we can't actually evaluate it using direct substitution. So in order to be able to analyze this, or at least look at the function, let's start by multiplying both the numerator and denominator, which is 1, by the conjugate of this. So we have the square root of x to the fourth minus 4, and then plus x squared, and the same thing in the denominator, square root of x to the fourth minus 4, and then plus x squared. When we do this, the square roots would go away for our first term, so we would have x to the fourth minus 4, and then we would have minus x to the fourth. Because we have a difference of squares, our middle terms would end up canceling one another out, and negative x squared times positive x squared is negative x to the fourth. And then we're going to divide this by the square root of x to the fourth minus 4 plus x squared, and that plus x squared is outside of the radical. We're going to take the limit of this function as x approaches negative infinity. Well, we can clearly see here that x to the fourth and negative x to the fourth cancel each other out, so we'll be left with negative 4 over the square root of x to the fourth minus 4 plus x squared. And we're taking the limit of this as x approaches negative infinity. If we analyze the degree of our numerator versus the degree of the denominator, the degree of the numerator is 0, and the degree of the denominator is going to be 2. And the square root of x to the fourth is also x squared. So we have a higher degree in the denominator. Therefore, as x approaches negative infinity or positive infinity, this function will approach 0, or answer choice C. And if we look at this graphically, we can clearly see that as x is approaching negative infinity, our function is indeed approaching 0. So that verifies the solution that we found. Answer choice C, 0.